Hey everyone, welcome back. In this video, we're going to explore the dataset for our robot collision prediction project. The dataset is this CSV file, and you can grab it from Kaggle on this page. You can also read more there about where the dataset comes from and how it was collected. This dataset is not perfect for collision prediction, but our goal is to learn how to handle real sensor data and prepare it for training a neural network. The dataset was collected during wall following, not random movement or collision-heavy scenarios. Most rows indicate safe movement, move forward, leading to class imbalance, where collision examples are underrepresented. Still, this dataset is great for learning how to load, process, and split sensor data in C++. Each CSV row in the dataset contains 24 sensor readings, followed by a label describing the robot's action. The labels include move forward, sharp right turn, and slight right turn. Since our project is a binary classification problem, we'll need to convert these labels into 0 for no collision and 1 for collision. Let's get started. Inside the csvloader.hpp file, we begin with the header guard, and here we say hash fndef csv_loader and hash define csv_loader and hash indf. And here we include the necessary libraries. Here's the first one, hash include iostream, hash include fstream, hash include sstream, hash include vector, hash include string, and hash include unordered underscore set. Unordered underscore set is a fast hash-based container for storing unique items like non-collision labels. And the next one is hash include iomanip. Iomanip gives us control over formatting output, such as setting precision for numbers. And here we have hash include functional. And this one allows passing functions as arguments. And next, hash include numeric, which provides numerical utilities. Then we have hash include random and hash include algorithm. Algorithm contains algorithm like shuffle for randomizing dataset order. And here's the last one, hash include log.hpp. Next, we wrap all functions in a CSV namespace to avoid naming conflicts. And here we say namespace CSV. Now, inside the namespace, we define a function to check whether a given label represents a collision. Bool is collision label, and it takes a label as input. Const std scope string reference label. Here we store all the labels that mean no collision in a static unordered set. Static std scope unordered underscore set std string, and we're gonna call it no collision labels equals, and inside curly brackets we say move dash forward. Move dash forward is the only one here, meaning it's safe. The static keyword ensures the set is created only once, the first time each collision label runs, instead of being rebuilt every time. This avoids extra work like memory allocation and hashing. Finally, if the label is not found in our save list, that means a collision, so we return true. Otherwise, we return false. And we do that like this. Return no collision labels dot count and we pass in label equals 0. Now we define a function to parse a single CSV line into sensor features and a label. It returns true if parsing is successful or false if there is an error in the CSV row. And here's the function, bool parse line, and it takes 4 inputs. Here's the first one, const std string reference line, the CSV row as a string, and std vector double reference features, a vector to store the 24 sensor readings. The next one is int reference label. This is an integer to store the mapped collision label 0 or 1. And the last one is const std function angle brackets int, and inside parentheses const std string reference label mapper. And this one is a function that converts the string label from the CSV into a binary label for a neural network. Inside the function, first we create an input string stream from the CSV line, std I string stream, and we're gonna call it ss, and we pass in line. This lets us treat the line like a stream so we can extract values one by one using commas as separators. Next, we declare a string variable to temporarily hold each value we extract from the CSV line as we parse it, std string, and we call it token. And then we create a vector of double, std vector double, and we're gonna call it temp features. This vector will temporarily store the 24 sensor readings from a single CSV line before we move them into the main features vector. Now we loop through the 24 sensor readings. For int I equals 0 and I less than 24 and plus I. Inside the loop, we grab the next piece of text, stopping at each comma. If we don't find a value, that means the line is incomplete, so we immediately return false. If not std getLine, and we pass it ss, comma token, and comma the separator, comma, and inside the condition we return false. Next, we use a try-catch block to convert the token into a double, and then push it into our temp features. But if the conversion fails, maybe the data isn't a number, we return false to signal bad input. And here's the try-catch. Inside the try block, we say temp features dot push underscore back, and we pass in std s2d string to double, and we pass in token. And inside the catch block, we return false. In the next step, we read the final value in the line, the label, and here we say if not std getLine, and we pass in ss and token. Since it's the last field in the CSV row, we don't use comma delimiter here. If the line ends unexpectedly and no labels is found, we return false to mark this row as invalid. And here we say return false. Now that we have the label as a string, we pass it into our label mapper function, which converts it into a numeric class ID. Label equals label mapper, and we pass in token. Next, we move our temp features vector into the features output variable. And here we say features equals std move, and we pass in temp features. Using stdmove avoids copying and transfers ownership efficiently. Finally, we return true to indicate that this row was successfully parsed. Return true. Now we define a function to print the class balance. Void print class balance. This function takes two inputs, the feature set and the corresponding labels. And here's the first one, const std vector std vector double reference features, and const std vector double reference labels. The purpose of this function is to count and display how many samples belong to each class, collision or non-collision. Checking the class balance is important because if one class dominates, the neural network could become biased during training. Inside the function, we first create two counters, size underscore t positive equals 0, negative equals 0. Positive holds the number of collision samples and negative holds the number of non-collision samples. Next, we loop through all the labels to count positives and negatives. For const auto reference label colon labels. Inside the loop, we check if the label is not empty and its value is 0.5 or higher. We treat it as a collision and increment positive. Otherwise, we treat it as a non-collision and increment negative. And we do it like this. If not label.empty and label square bracket 0 is greater than or equal to 0.5, we increment positive plus plus. Else negative plus plus. Next, we get the total number of labels in the dataset. Size underscore t total equals labels.size. And then we calculate the percentages of the positive and negative samples. Double pose underscore percent equals 100.0 times positive divided by total. And double neg underscore percent equals 100.0 times negative divided by total. Finally, we print out the information about the class balance so we can see the distribution of our dataset. We also log it into the log file, like this. Now we define a function to read the dataset line by line and load the sensor data together with their labels. Bool load sensor data. This function takes several parameters, and here's the first one. Const std string reference file name, the name of the CSV dataset file we want to load, and next std vector double reference features, a vector of all 24 sensor readings. And then we have std vector double reference labels. Next, std vector int reference IDs. This is a vector of integers that uniquely identify each row by its index. And the last one, const std function angle brackets int, and inside parentheses const std string reference and reference label mapper. This is a function that converts string label into numeric IDs 0 or 1. Inside the function, First, we create an input file stream to read from our dataset file. Std if stream, and we're gonna call it file, and we pass in file name. Then we check if the file was successfully opened. If not, we print an error message and return false to indicate failure. If not, file.is_open, and here we print the error message. std car failed to open file. And we also print the file name and add /n here. Then we return false. Here we declare a string to hold each line we read from the CSV file. std string line, and an integer to assign a unique ID to each line as we process it. Int line_id equals 0. Then we loop through all the lines in the dataset to read and parse them one by one. So here we say while std getLine, and we pass in file and line. Inside the loop, first we declare a vector of double to store the 24 sensor readings from the current line. std vector double sample. And we need another variable to store the label for this line, int label. Then we check if the current line can be parsed correctly. If parse line, and we pass in line, sample, label, and label mapper. And if the parsing was successful, we add the current sample's 24 sensor readings to our features vector, features.push_back, and we pass in sample. Next, we store the label for this sample, labels.push_back, and we pass in inside curly brackets static_cast double, inside parentheses label. We cast it to a double and wrap it in braces, which creates a vector of double with just one element. This way, the format matches what our neural network expects later. Finally, we assign an ID to this sample by pushing the current line_id into our IDs vector, IDs.push_back, and we pass in line_id++. At the end, we return true if feature is not empty. Otherwise, the function returns false. Return not features.empty. Alright, that's it for this video. We have built our loadSensorData function, and now we can read the dataset line by line into features, labels, and IDs. In the next video, we'll finish up this file by creating two more functions. One to load and split the dataset into training and test sets, and another one to shuffle the data. You can download all the project files from my GitHub. And thanks for watching. I'll see you in the next one.